Hello everyone and welcome to our next lesson, which is 10.2. It's on logarithms. Logarithms is a section in this chapter that is kind of difficult for students to understand right away. It's difficult to grasp. It's kind of abstract. But with enough practice, the repetition helps these problems become easier and easier. So here's what logarithms are used for. They're used to help us solve exponential equations. I ask you this question: 2 raised to x, when does that equal 10? Well, I know 2 squared equals 4. 2 cubed is 8, so we're getting closer. 2 raised to the 4th is 16. Now we're too high. So I know that x has to be somewhere that is bigger than 3 but less than 4. What number is that? Well, one way that I could do it that isn't very good, I guess, is I could put it into my graphing calculator and then use this trace key until we get it somewhere close to 10. But we're not going to get it very exact. So what's better is to use logarithms. So a basic general definition: a logarithm is another way to write an exponent. They're the exact same thing, they're just written differently. So the general definition is listen as I read this. It's log with base b of x equals y. So listen to me read it again. Log base b of x equals y. A logarithm is the exponent y that makes b to the y equals x true. This might sound like a bunch of gibberish to you right now. This is an example. We're going to do several more here. Log base 8 of 1 equals 0 is true if the base raised to the number on the right side, which is 0, equals 1. So now that you're completely confused, let's just do some example problems. If I have 2 raised to the 3rd equals 8, I said that logarithms and exponentials are the exact same thing, you just write it differently. So here's what it is. 2 cubed equals 8. That's a true statement, yes? Yes, it is. So now if we change this into logarithms, you take the log with the same base, log base 2 of this number on the right, which is 8. That equals my exponent, which is 3. So class, even though this looks completely different than this, they say the exact same thing. 2 cubed equals 8, and log base 2 of 8 equals 3. Mathematicians have written it this way to help us solve exponential equations, and you're going to see that coming up in this section. Let's do 2 more example problems so you can kind of get used to it. If we have 5 squared equals 25, this is a true statement. If we write this in logarithmic form, it's a log with the same base, so log with a base 5 of the number on the right, so log base 5 of 25, that equals my exponent, which is 2. Log base 5 of 25 equals 2. These say the exact same thing. Okay? Last one, we'll say 3 raised to the 4th equals 81. So the exact same thing, changing into logarithmic form, would be a log with the same base, so log base 3 of 81 equals 4. Now, like I said, why do we use logarithms? Next page. Logarithms are the opposite of exponentials. So math is all about opposites when we solve equations. Opposite of subtraction is addition. Opposite of division is multiplication. Opposite of the square root of something is squaring it. Opposite of the cubed root of something is cubing it. Opposite of the sine function is the inverse sine function, right? Math is all about opposites. So logs are the opposite of exponentials, or they undo each other. They are inverses of each other. So this is going to be very valuable when you get stuck solving an equation. Oftentimes, if you just change the form, if it's in logarithmic, change it to exponential. If it's in exponential, change it to logarithmic. When you do that, this word undo, using it as the inverse, it helps you solve problems. All right, let's look at the first one. Write the following into exponential form. So right now they're in logarithmic. So what you're going to do is you're going to keep this same base. It is 2. Okay, you're going to raise it to the exponent, which is the number on the right. 2 raised to the negative 4th, that equals 1/16. You could always check these in your calculator to make sure you did them right, because this is the same thing as this. So why don't you check it in your calculator? What is 2 raised to the negative 4th? What is 2 raised to the negative 4th? We should get 1/16. And we get 1/16. So if you want to, you could always check these in your graphing calculator. Let's try letter B. If we want to change this logarithmic into exponential, we say it has the same base, which is 5, raised to the number on the right, which is 2, that equals this number on the left, which is 50 halves. 50 halves is the same thing as 25, and what is 5 squared? 5 squared is 25, so 25 equals 25. So that's how you go from logarithmic form to exponential form. Now let's go the other way around. We're going to write the following into, yes, logarithmic form. Did I write this down right here? Yes. Okay. Write the following into logarithmic form. So to write into logarithmic form, you need to see a log in there. It's a log with the same base. So log base 10 of the number on the right, log base 10 of 1,000, that equals 3. It equals the exponent. Log base 10 of 1,000 equals 3. In the same way, we have a log with base 9 of the number on the right, 3, equals 1/2. If you kind of want to think about these two numbers just changing places to go from logarithmic to exponential, I'm okay with you thinking of that. It's not the exact same thing, but in a way, this goes to the left side of the equation, this goes to the right side of the equation. If that helps you, certainly think of that as you're doing these. Evaluating logs. So log base 2 of 64, what does this equal? It equals, I don't know, we're going to call it x. So log base 2 of 64, what does it equal? Let's find x. When we're stuck, S-T-U-C-K, stuck, we need to change forms. So right now this is logarithmic. Let's change this into exponential form. So we would say it is the same thing as 2 raised to the x equals 64. The base raised to the number on the right equals 64. And now we can solve this using yesterday's lesson of getting common bases. 2 raised to the x, 64 is the same thing as 2 raised to the 6th power. 2 times itself 6 times equals 64. So now our bases are the same. So what does x equal? X equals 6. Let's try it again, letter B. What does this equal? We don't know. Let's call it x. So log base 16 of 2 equals x. Well, let's change this into exponential form. So 16 raised to the x power equals 2. 16 raised to the x equals 2. That's how we changed into exponential. Let's get ourselves some common bases. 16 is the same thing as 2 raised to the 4th power. 2 raised to the 4th raised to the x. That equals 2 raised to the 1st, really. So now we have common bases of 2 and 2. So this equals this. 4x equals 1. So what does x equal? X equals a 4th. That's the answer for letter B. And finally, letter C. Evaluate this. What does this equal? It equals x right now. So now let's solve. 2 raised to the x power equals 1/32. So 2 squared equals 1/32. This right here is the same thing as 2 raised to the 5th power. So if I want to write this using common bases, I would say 2 raised to the x equals 2 raised to the negative 5th. Because I can move this to the numerator and simply change the sign on my exponent. So what does x equal? Common bases, x equals a negative 5. So hopefully that makes sense. It's hard to understand at first, but once you get the process down, it's the same every single time. So that's helpful, hopefully. Looking on the next page. Log base 2 of x equals 3. What does x equal? We're solving logarithmic equations. When we're stuck, when we don't know what to do, we have to change forms because logarithms and exponentials undo each other. So right now I don't know how to solve for x, so immediately I got to think, let's change the form. It's in logarithmic, let's change it into exponential. So exponential would say that my same base of 2 raised to the number on my right, which is 3, that equals x, the number on the left. Remember, these two just kind of change spots. So 2 cubed equals x. What is 2 cubed? Well, it's 8. 8 equals x, and I successfully got x all by itself. X equals 8. Let's try letter B. The log base 9 of x equals a half. Well, if this is in logarithmic form, I'm going to change it into exponential. So it's going to be 9 raised to the 1/2 power. That equals x. Now all we have to do is just raise 9 to the 1/2. You can do this in your calculator, but remember the 1/2 power is the same thing as the square root. So what's the square root of 9? It's 3. So x equals 3 for this one. Moving on to letter C. Log base 4 of x equals 3/2. What does x equal? Well, let's change this form. It's in logarithmic. Let's change it into exponential. So 4 raised to the 3/2 equals x. This goes off to the right. This goes off to the left. So 4 raised to the 3/2, that equals x. So what is 4 raised to the 3/2? We can do that in our calculator. 4 raised to the 3/2, and we get the number 8. So our answer for this one, x equals 8. Last one of this kind, letter D. The log base a of 16 equals 2. So what does a equal in this case? Well, I'm going to change forms, so I now have a squared equals 16. I'm changing it from logarithmic into exponential. Let's get a all by itself. How do you get rid of that square term? Square root both sides. So a equals the square root of 16, which is plus n minus 4. I'm going to throw a wrinkle in here, class, and I'm going to describe it more tomorrow. You can never take the log of a negative number. So the log of a negative 4 is undefined. So if we have a equals 4 and a equals a negative 4, you can never take the log of a negative number. So this is out. Your only answer is x equals the positive 4. I'm going to explain that tomorrow when you get to class. So just remember right now, you can never have a negative log as a base. Okay, last thing for today. I know it's been a lot. The property of equality is simple enough. It just says, here's my equation. If on the left side I have a log with a base, and on the right side I have a log with the exact same base, as long as it's equal those bases, you can simply set x equal to y. Okay? So as long as it's a log of the same base, you can set those two quantities equal to each other, or x equal to y. So simple enough. This is a log base 5, and this is a log base 5. So now you could simply set these two equal to each other and solve for x. So x plus 7 equals 2x. Subtract an x. That would mean x would have to equal 7. And there's my answer for that one. So these ones are relatively simple. Log base 32 and log base 32. If you know that they're logs with the same base, you can set 10x equal to x plus 81. Subtract an x from both sides. And now we have 9x equals 81. Divide both sides by 9. So x equals 9. And that's my answer for letter B. Last one, letter C. log base 5 and log base 5. So if the logs have the exact same base, you can set p squared minus 2 equaled to p. So now this becomes a quadratic, or we're going to solve using a quadratic technique. Subtract p from both sides. So now on the left we have p squared minus a p minus 2 equals 0. Now to solve for p, we're going to factor. So we have p multiplied by p and a minus 2 and a positive 1. So p minus 2 equals 0 and p plus 1 equals 0. That means p equals a positive 2 and p equals a negative 1. Always be very careful when you get a negative number, because you can't take the log of a negative base, nor can you have log base b, or log with a base number of a negative number. So this right here would say log base 5 of a negative 1. And you can never ever take the log base of a negative number. This is impossible to do. It's undefined. Once again, I'll explain that to you tomorrow in class. So this is not possible. Our only answer is p equals the positive 2. Our assignment for today, class, is going to be objectives 110, 111, 112, and 113. These logarithms might seem kind of overwhelming at first, but I promise you, class, once you get that logarithmic form and exponential form understood and how they kind of undo each other, these problems actually become very, very simple. Okay? So take heart if you're discouraged right now. The more practice you get, the better you get at it. Please ask me any questions if you're confused about this when you get to class tomorrow.